Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 153. Please turn to it. Page 153, and today is our lesson number 274. These problems that you see there on page 153, two problems, are the exact same problem that appeared on the exact same page number in the first edition of the revised GRE. And therefore we have solved these problems already. If you need to watch the solutions to this problem at a slower pace in more detail, you can go to the original video, which was on day number 46. And on day number 47, we did the problem very similar to the ones that you see here, very similar to problem number 11. That was a bonus problem on day number 47. Let's put it on this side so it's not in the way. Day 47 was the bonus problem, which is very similar to the problem that we are about to solve, number 11. So let's get going. We are given a garden, a rectangular garden. I shouldn't have put it there now because this is we have here what they are referring to as a rectangular garden. We are told that the garden is 18 by 12 feet. We are also told that the walkway that we see around it, the border, we are told, is 3 feet wide all the way around. Question is, what's the area of the walkway? Question is very straightforward. Question simply is, what's the area of the walkway? Well, let's see what we can do here. So we are told that the garden itself is 12 by 18. So this is 18 feet and this is 12 feet. That was the easy part. 18 by 12. Question is, how much is it from here to here? How much is it from point A to point B? Can we find that out? Well, that's quite straightforward. From here to here, this border is 3 feet, and on the top it is 3 feet. So A to B must be 12, that we see here, 12 plus 3 plus 3. 12 plus 3 on the top and 3 on the bottom. 12 plus 3 plus 3. Similarly, A, B, C and D. Similarly, A to D would simply be the 18 feet that we see here, 18 plus the 3 feet on this side plus the 3 feet that we see on this side. So now we can figure out the area of our walkway. All we have to do is, area of our walkway is going to be equal to the area of the outer rectangle, which is what we're calling ABCD, minus the area of the garden, which is 12 by 18. That's all, we're done. And that's simply 12 plus 3 plus 3, that is 18 by 12 plus 3 plus 3, which is 24. So it's 18 times 24 minus the area of the garden, which is 18 times 12. Okay, watch what happens. I'm going to continue this from the top so that we can see it easily. Or perhaps I can continue here. Now 18 times 24. Listen carefully. 18 times 24 can be written as 2 times 18 times 12. Of course, why not? Because we are writing 24 as 2 times 12 minus 18 times 12. So it's like this. It's like this. It's 2 times x minus x. X here is, your x here is 18 times 12. That's the quantity that we're calling x here. So if you have 2 times x, which is 18 times 12, 2 times x minus x, well, that's just x. So that's it, we're done. So this quantity, 2 times 18 times 2 times 18 times 12 minus 18 times 12 is simply 18 times 12. 18 times 12. And how much is 18 times 12? If you were to come up to me and ask me how much is 18 times 12 in the middle of my sleep, my answer simply would be, how the hell do I know? I know 18 times 10 is 180. 18 times 10 is 180. That represents 10 18s. We have 12 18s. So we just have to add 2 more 18s to it. So 8 plus 8 is 6. Carry 1. We have 3, 11, 1. There you go. That's it. The answer is 216 square feet. Square feet. Area of the walkway is 216 square feet. That's it. We are done. Let's move on to the next one then. On the bottom of the page. One more time, I'm going to actually show you one more time very quickly as to how we figured out the area of the walkway. The outer part is this is 12. From here to here is 12, and then we have 3 feet at the bottom, 3 feet at the top. So this actually becomes 18. A to B is 18. Similarly, A to D is 18 feet here, 3 feet on this side, 3 feet on this side. So it's 18 plus a 3 plus a 3. So it's actually the outer side is actually 18, which is this part right here, times 24, which is this part right here, minus the area of the garden, which is 18 by 12. And what we did is, we wrote this part as 18 times 12 times 2 times 18 times 12. This quantity minus this quantity. So we have 2 of this quantity right here, and we have 1 of this quantity. So it's basically 2 times x minus x, which is simply 18 times 12. Which is simply 180 plus an 18 plus an 18. That's it. Let's move on then to the next problem, which is the geometry question. Line K, we are told, has an x-intercept of -4. So this is page 153 again, number 12. This is something that was done on day number 48. If you want to watch the original video, that is. Line K has intercept, x-intercept of -4. Line K with x-intercept of -4. Line K, we are also told, passes through the midpoint of a line segment whose endpoints are, let's give this endpoint's name. I'm not sure if they give them name or not. They don't give them name. We're going to call them A and B, just so we can talk about them. We can christen them A and B, and B, which is 2 and 0. And the question is very straightforward. The question simply is, what's the slope of line K? And as I always remind you, questions of course are always straightforward. It is the answer that gets prickly. So let's digest everything. Let's make sure we understand everything what is being said to us. Line K has x-intercept of -4. So let's draw our coordinate system. -4. X-intercept, you understand, which means it cuts the x-axis at -4. 1, 2, 3, 4. It cuts here, right here. We are also told that line K passes through the midpoint of another line whose endpoints are 2, 9 and 2, 0. Let's look at these 2 points, shall we? 2, 9 and 2, 0. Point A, we are calling it 2, 9. 1, 2 and then 9. Let's call it 3, 6 and 9. 2, 9 which is what we're calling point A, 2, 9. They don't give it a name, but we're going to give it a name, and 2, 0. 2, 0. That's our point B, 2, 0. Our job is to figure out where the midpoint of this line segment is. One more time, we are told the line K passes through the midpoint of a line segment which goes from A to B. That's your line segment right here, which is a line segment whose endpoints, these are the endpoints. This is where it begins from, this is where it ends. Whose endpoints are 2, 9 right here, 2, 9, and 2, 0 right here. What's the midpoint of this line segment? Well, very straightforward, very simple. We don't have to worry about the x coordinate because this is 2 and this is 2, which means that the line segment AB is actually parallel to the y-axis. We just have to figure out what the midpoint is going to be if it goes from 0 to 9. Well, the midpoint from 0 to 9 is 4.5. Well, you just take the half of the distance. 0 to 9 is 9 units. Half is 4.5. Half of that is 4.5 right here. Let's call it point C. Let's call it point Q. So this one has a 2 and a 4.5. I call it point Q so that we don't confuse this point right here, Q, with the point A and B. Point A and B have nothing to do with point Q here. Point Q is the line that we are interested in, which is right here. Let's call this P, which we are told has an x-intercept of -4. We're calling this x-intercept of -4. So that's our point P. So that's it. The line that we are interested in, line K that they're talking about, is this line right here. It's this line that looks like this. It goes from P to Q. There we go. That's our line, P to Q. That's line. And that's what they're calling, this is what they're calling line K. Well, that makes our life simpler actually. All we have to do now is figure out the slope of the line, which cannot be that bad because we already know the 2 points that it goes through. It goes through this point, point P, because that's the x-intercept of -4, which means it cuts the x-axis at -4, which means it goes through a point P with the coordinates of -4 and 0. And we also know that it goes through point Q, which happens to be the midpoint of A and B, which is 2 and 4.5. That's it. Let's figure out the slope, shall we? Let's do it on the top. Or we can continue here. The slope of line L, what's the slope of line LK? What's the slope of line K? The slope of line K is going to be rise over run, which is the change in y over the change in x. And the question is, what's the change in y coordinates as you go from point P to point Q? Well, point P has a y coordinate of 0. Point Q has a y coordinate of 4.5. So it goes all the way from 0 to 4.5. Therefore the change is 4.5. Change is 4.5. What's the change in the x coordinate? This is where you have to slow down. What's the change in x coordinate? X coordinate goes all the way from -4 to +2. From -4 to +2. From -4 to +2 is 6 units. Because -4 to 0 would be 4 units, and then from 0 to 2 of course is 2 units, so it's 6 units. So change in x is 6 units. That's it, that's our slope. But of course we cannot leave it like this in such an ugly manner, in such an ugly state. We have to fix it, make it look more elegant, make it look a little bit more presentable. Let's do that, shall we? It's 4.5 divided by 6. 4.5 divided by 6. Somehow we have to get rid of this half. The easiest, simplest, quickest way to get rid of half whenever it appears in anything is to multiply the damn thing by 2. So if you multiply the top by 2 to get rid of the half, because now 4.5 times 2 is just 9. We have to if you multiply the top by 2, we have to multiply the bottom by 2. 4.5 times 2 is just 9. 6 times 2 is just 12. And we're almost there. Divide top and bottom by 3. And this 9 becomes 3 and this becomes 4. The answer is 3/4. The answer is the slope of the line that we were interested in, which they refer to as line K, happens to be 3/4. Positive 3/4, that is, as you can clearly see, is a positively sloped line. That's it, we're done. Tomorrow we'll do the next 2 questions that you see on the following page. Page number 154. And those are again the same problem that we did on day number 49 and 50 already. In case you want to watch the solutions ahead of time, As I said, if you need more help, if you need to go at a slower pace, that's what they're meant for. I'll see you tomorrow, okay? Bye now.